Hi, I'd like to go over a couple more examples from section 5.2. This first one, we have secant minus cosine on cosecant on one side, and then an expression with sines and cosines on the other side. Now, this side might look more complicated, but I think we'll find that it's actually easiest to start with secant theta and cosecant because those can be changed into sines and cosines, and they maybe give us a more clear way to start. So as is true with I'm going to start by making this into an expression with sines and cosines. And now I see that I'm subtracting fractions, so I want to go about trying to do that. So I need to have common denominators. So I'm going to multiply this first fraction by sine over sine. And I'm going to multiply the second fraction by cosine over cosine. And then this gives us, this is going to give us common denominators because you're going to have now sine theta over cosine theta sine theta minus cosine theta over sine theta cosine theta. So now you can clearly see the two denominators are equal, and so I can subtract these two fractions. I can combine them into one fraction, sine minus cosine over cosine theta sine theta, which is exactly what my goal was and what I wanted to get to. So really didn't have to think about it. Once I got simplifying, it simplified out to that expression that I was looking for in the first place. Okay. All right, let me take a look at one more here. This one, maybe a little more interesting. Clearly, the left side is the more complicated side, and it looks like I might be able to do something there. So again, what I do with these identities is I start by just rewriting the side that I'm going to work with. Because I'm not solving an equation, I'm trying to prove that this expression is equal to this expression. So I've got to take this and work on it until I get here. Do not treat this as an equation and work down on both sides of the equation. Instead, just pick one side and work on it. Now, I notice that this right here is a difference of squares. It's 1 squared minus sine squared squared. So this can be factored out and broken up and written as 1 plus sine squared theta times 1 minus sine squared theta. Okay, which is very good news because look at the denominator. The denominator is equal to this factor. And so this is good news. I can cancel those out, leaving me with 1 minus sine squared theta. And this is one of our Pythagorean identities. 1 minus sine squared is equal to cosine squared. And just like that, we're done. We got what we were looking for.